Okay, got the turbine all put together just now. Got the motor mounted on the mount. Wire just comes. This actually only has one wire that goes down to the tower, so that'll go straight down through here. The bottom of the top of the tower will be just an eighth of an inch or so off right here. But that's pretty much it. The ground for this motor goes into the tower itself, so I tap out from my negative right through the tower at the base. And it seems to spin pretty easy. Continues to spin without anything being added to it, so quite excited to get this on the tower. Got some things wired together. I'm going to do a little test to them. Here's my deep cell battery. I ended up buying these gator clips. Originally it only had one screw in it, so I made this little port hub. I found these little brackets at the store, so I can plug four things into it or whatever. So I did that for both positive and negative. Now the thicker wire is an 8 gauge that goes directly from the battery into the back of the grid tie inverter, and the smaller gauge, positive and negative, is going to the charge controller. This is what it'll actually keep the battery charged and give the power to the whole system from the wind turbine and solar panels. A charge controller is dual, it can work for both. So here's kind of how they connect into the inverter. It's a fused inverter. There's 3 fuses. It's a 1,000-watt pure sine grid tie inverter. Grid tie meaning that instead of having a outlet at the end, it's got an outlet like this that you plug right into the wall, and it feeds your grid just like that. So here is pretty basic charge controller. I did forget to buy the another part for this, so I've got that on its way. It's a relay where the power actually comes into it, and it determines if the battery is full or if the grid is down and then the battery gets full. Instead of overcharging the battery, that relay will divert the power elsewhere into basically just a heat source. So now I'll turn on the grid tie inverter. My thing turned off. I think if I just touch the button, it turns back on. Yep. So the grid tie inverter is at run. When it's flashing, I'm making power, putting it into the grid, and so we'll watch the watts grow on my kilowatt meter. With no load onto this, just the battery draining itself, it'll top out with this inverter at about 130 watts. So 134, 135, usually go right back down to 130. And you can see I started out with 12.8 volts, and now I'm down to 12.4, 12.3. So if I had a charge coming into this, my charge would be in the 13 plus range, and my wattage would increase due to that. This grid tie inverter does anything from 10.8 volts to 30 volts. So if I get to the point where this battery gets below 10.8 volts, the grid tie inverter will just stop working until the wind turbine increases voltage through this charge controller and boosts the battery back up above 10.8. So for now, that's what I got going. I got to start mounting all this stuff together, and in a couple days I'll have the part for this. For now, I'm just going to wire this straight from the tower into the grid tie inverter. It can be dangerous to do that, not so much for myself, but for the piece of equipment, the grid tie inverter itself. Only in the case that the grid were to go down. This inverter can sense if the grid is live or not live, and it shuts down if the grid shuts down. So that power has to have somewhere to go, or else it could damage that. That's what the relay, the charge controller, the battery, and the heat dump are for. So I'll show that all set up once I get it. So I've gotten a little further into my wiring of everything. Let's switch on this other light here. There we go. So I got the grid tie inverter plugged, screwed on. I've got the charge controller screwed on. I really like these brackets here. These are sold as just mending brackets. I don't know if I can, well, lights on, but mending brackets anyhow. They're like 4 inches or so. There's 4 holes in them, and they come with screws. Granted, I don't use those screws because I got tons of other screws. But these actually are zinc plated, I believe, and they work really well for making these little bus hubs really cheaply. I think I get 4 of them for under $4. So this was like $2 worth right here. But anyhow, from the charge controller up, I'm going to be going into some relays, and each relay can do 1200 watts, and this controller can do up to 3 relays, and it's expandable. So that's why I've made this huge board, is because this is my diversion dump load, and that's 600 watts, and I have room for 5 of them, which would give me 3000. And then I have a 1000-watt power inverter here, which I have room for about 4 more. Probably would just do 3, maybe, I don't know, who knows what the future holds for me. So I left this board expandable. I'll have room for the relays. They'll take up, I don't know, this whole middle section here with the wiring and everything. And then at the top here, I've got this normal power inverter that has normal outlets on it, just normal AC supply. So if the power grid goes down, I can plug into this and feed off whatever. Last time the grid went down, we had the whole living room powered off of this inverter here. So I got to get some alligator clips. I think the plan's going to be just to hook some alligator clips on the positive and negative terminals, and hook up a ground. There's a ground wire to this one too, so this has to be grounded. And I think I'll just put alligator clips on there, and when the power grid goes down, I could just walk down there. Probably at that time the diversions will be running, draining the batteries, and I'll just hook into the batteries with these 2 wires here, and I'll have that permanently grounded, ready to go once I get it set up. So then coming into my battery, I've got quite an array of wires going on now, and there's still more to come. So on the positive side, I've got just going from the charge controller to the inverter here, and that's another one of those bridge things I made, or whatever you want to call it. And here's the negative. I've got this one hooked up, so it's gonna go from the battery right to the diversion. And then how it's going to work is going from the wind turbine to the negative, I believe. Let's see, I've got a little diagram here. So here's kind of how it's gonna look. So the wind turbine negative is going to come to the battery. So I'll have a negative from the wind turbine, and then positive from the wind turbine into the relay switch. And then the other side of the relay switch from where the wind turbine will come in will be my positive on my diversion dump. And then we'll go battery to the same area where the wind turbine comes in to the relay. So the right side of the relay there will be another one of my bus hubs for the positive from the wind turbine in case the relay is closed. If the relay is closed, it's going to feed down into the battery, into the charge controller. But yeah, so this is kind of the new thing I've came up with. I think that's going to work good. This, like I said, this charge controller can handle 3 of these 100 amp relay switches. 100 amps times, and I'm on a 12 volt system, so 100 times 12 is 1200 watts. That'll be able to handle. And then I can do up to 3, so I can do up to 3600 watts off of this little tiny controller here, which is pretty sweet. And I got a lot of room. I kind of like how I got the inverter set up. The outlet source is on the left of where this panel will hang, so that'll work well. And the top of this is going to be about 5 feet up, so that I can get power off of this and see the top of that without bending down or really doing anything. I just finished setting up the wind turbine and trying to get a shot at it. It's kind of dark and it's spinning quick. It is windy tonight, but she is tracking and working just fine. A little view of it. You can hear it. I'm gonna wander in to see if I'm producing electricity or if it blew up stuff. Nobody's going on right now. Just set up the wind turbine. I got it directly wired into the power inverter for the time being, but I am producing my first wattage here. It's not a lot, but it's measuring. Possibly I should be using higher size wire than these. I'm gonna have to fix that. It's just going through the bridge rectifier, which changes the 3-phase AC into DC straight into the inverter. So anytime my red lights or my green lights blink and I'm producing, I'm just getting random gusts up there right now. So now we're starting to kick in something again. So anyhow, we'll see what we show up with in the morning when we click on our kilowatt button and see what we've made. I suppose I probably should unplug this and get a real feel. This thinks it's been on for 8 hours already. It's just when I first plugged it in. I think I'll do that now. Oh, here's the finished product. It's barely a breeze today. It's blowing about 8 miles an hour. According to the manufacturer, this is 8 miles an hour is when it's supposed to start producing electricity. I haven't seen a noticeable amount yet, so tomorrow I'll come back and look. It'll be blowing about 16. We should get some good wattage off of that. It definitely tracks good. Follows the wind. It starts up spinning pretty low speed, like 5 miles an hour, if that.